Oh, hello, welcome. It is now 4 o'clock and we are going to get started. I am so pleased you're here. This is the last, the final, the fourth. I am just bemoaning the fact that there are only four
There's
seasons.
only 4 seasons,
Yeah,
Leslie.
can we do something about that so we could we could keep this joy going? I am Leslie Esslinger, and I am with Becker School Supplies. I am your host for today, and we have a whole team of Becker's folks that are with us in the chat room, waiting to answer questions, etc., etc. So we're so pleased you're here. We do hope that you will stay till the end. I know you're all very, very busy, but we have some exciting new products to announce, and also we have a special promo code for you. So hang in there. The next slide, we'll do a little housekeeping. So, as many of you know, since so many of you are regulars, you will get a certificate. It'll come in as an email to whatever email you use to register with. Give us 24 to 48 hours to receive that. If you do have questions for our team, please put them in the question answer box. And as I said, Marilyn and Terry are there to answer them. And whatever questions Holly doesn't get to, she might have a little time at the end to try to address them. You know that Holly loves polls if you've been with us before. So we don't be shy. We have polls. The feedback is really important to us. So just thanks if you could participate in that. And as we did say, while a few of you were here a bit early, that this session will be recorded, as well as the last 3 seasonal webinars have been recorded, and they're available at that link. And that link will be repeated throughout the session in our chat box. And next. And I forget this part, but I'm not sure if you're introducing yourself, but I'll say a few words first. And I won't do the regular stuff because a lot of you know Holly, but I did come up with just some quick descriptors of who
Oh
this
no.
person is. She is fun. She is lively. She's charismatic. She's personable. She's knowledgeable, and I'd almost say she's so very humble. But I'm not sure by the end of this, when we compliment her so much, I don't know if she'll be able to maintain that beautiful,
My
humble
head, my
nature
head's getting a little heavy,
that
Leslie.
that she has.
So big.
But just put your seatbelts on, folks, because you are in for a fantastic session with Holly. Lots of exciting things are coming your way. So I'm going to shut down, and it's all yours, Holly.
Oh, thank you so much, Leslie. Hello, everyone. Welcome back to all of you who've been with us before, and welcome for the very first time to some of you. This is the 4th in the seasonal science series. As Leslie mentioned, all of them are recorded, so go back and check out the other seasons that you missed, but let's talk summer. I'm really excited about summer. Before we get started, this is all the really important stuff when you're trying to fit it into your curriculum and trying to fit it in with all the other great stuff you're doing. Everything we're presenting today does align with all of these fantastic standards. I'm not going to read them to you. If you need to go back and sort of cross-reference, they're in this presentation. They're also going to be on the step-by-step resources that you'll have that will be available after the webinar. So you can check that out. So those of you who've been with me, this is kind of my standard spiel about science for littles. I know when kids get older, they spend a lot of time talking about content. So it's learning all of those bits and pieces that we all learned when we were doing science in school. But for preschoolers, the most important thing is really we just want them to be excited about learning science and doing all of the cool things that go along with it. So there are 2 really, really big skills that we want to practice in early childhood education is making observations. Unfortunately, by the time they get to like 1st grade, no one talks about their senses anymore, which is a bummer for science. We need everybody talking about their senses all the time because that's what makes for a good scientist. And then, of course, asking questions. Preschoolers are perfect at asking questions. That is their jam. But the more we can get them asking questions about the world around them, the better scientists they're going to be. And then, of course, there's all sorts of other things that come along with science in the early childhood classroom, things that I'm sure you're all aware of. But I love, love, love talking about science for our littles. Okay, My first poll, since apparently I love polls, according to Leslie. Are your science lessons mostly demonstrations? So that's a teacher-led presentation where you sort of do something and the kids are watching. Or do you do hands-on experiments? So as soon as the little poll pops up, let us know, because that's important for us to know as we move forward and offer more resources for you in your classroom. This sort of information really helps us. So while you're filling that out, I'm going to move on to our first subject. So what's summer without the sun? Summer is the perfect time to look up in the sky. So we're going to learn a little bit about how we can make the sun, which of course is so far away, sort of present and available to our students. So the first thing is light. Okay, now if you were with me for kitchen science, we already have done some experiments with lights and shadows. But now let's talk about the sun. The sun gives off all different kinds of light, as you can see from my picture here. All these different kinds of energy, some of which are light we can see, like the visible light right in the center. Some of it we can't see. Actually, most of it we can't see. We can't see the X-rays or the radio waves or the gamma rays or even the ultraviolet waves, which is what I want to talk about now. So we all know that wearing sunscreen is really important. And I am sure you've switched to slathering the kids up before you bring them outside for recess. It is a process, I know. But that sunscreen and that sun protection is so important. And I've got a neat little experiment to help make sort of that importance known to your students. So what I'm going to do is I'm going to switch over to my little camera so I can show you some of the pieces of this experiment. So I'm going to switch to my second camera. So you can see here, I've got sort of this jar of beads. These beads are not terribly impressive. They're just white beads. But these beads are actually UV sensitive beads. So when I put them in the sun, or in this case, under a black light or a UV light, you can see now they're all a beautiful color, because what they are is they have pigments in them that respond to UV light. So there's obviously light in my room, but they didn't actually change color until they were exposed to this very specific wavelength, this UV wavelength. That's the one that we need to protect ourselves from with sunscreen. So while we can't see the UV rays, we know they're dangerous, and telling kids that they need to wear sunscreen and stay in the shade and all that sort of stuff is really important. But until they can see that change, like when that light is hitting those beads, it may not hit home the same sort of way. Now you can use these beads to kind of show the importance of using sunscreen. So let's go back to my camera here, because I picked the wrong camera. There we go. There we go. So we've got my beads here. Now you can see I put them on a pipe cleaner. So if you have littles and you don't want to just give them a bowl of beads, understandably, just put them on a pipe cleaner. So that way you can still have the experience of changing those colors in the sun. But you don't have to worry about possibly swallowing those little beads. So what I've got here, I've got 3 cups. Okay. And these cups are all just sort of normal paper cups. And inside are some of those UV beads. I've covered each top with a little bit of press and seal. You can use cling wrap, you can use whatever you'd like just to sort of cover the top. I've also labeled them. It actually looks like it's backwards, which is a little bit of a bummer right now. I don't know if it's backwards for you or not, but it does say lotion SPF 55. This one says spray SPF 70 plus.
It's good. It's not backwards, Holly.
Fantastic. Thank you, Leslie. It looks backwards from mine. And this one says no sunscreen, and it's got a little no on it. So basically what we're going to do is we're going to test how well different sunscreens can protect us or protect our beads from the rays of the sun. Now, you can see that I'm using my UV light because I'm actually not outside. If you are doing this experiment, you would want to definitely go outside. You can put some of your cups in the shade. You can put some of your cups under, you can put them under a sunglasses. There we go. That's a word. So I'm going to spray on that one, and I'm going to leave this one the way it is. So what you're going to do is you're going to put different sunscreens or different types of clothing over the top of your cups. Now, you would put them in the sun, but I'm going to put my little UV light over top of them. I'm going to do this one, I'm going to do this one, and I'm going to do this one. Okay, so I've given them both, I've given all three of them about the same amount. So first, the one without sunscreen, you can see we got colored beads in there. Now let's go to our lotion sunscreen, which got the same amount of sun. They're still white because the sunscreen did its job. It blocked those UV rays. Now, this one was our spray sunscreen. So it had the highest SPF, which means it should be blocking the most amount of the rays from our sun. But if we look in here, actually, I may have waited a little bit too long, but you can see some of them are a little bit blue. Now, why is that? Well, it's because it's a spray sunscreen. Sometimes spray sunscreens don't cover us quite as well as a lotion sunscreen would. But this is a great variable type experiment for your students because you can change a lot of variables very, very quickly. And it's easy to keep a constant or a control. So just having those beads without any sort of sunscreen on them, you can you have a constant control that's easy to compare with all of your different variables. So that's one of my favorite ways to use these UV beads. Some people put them in bags and then will like spray them or put the sunscreen on them. To me, that's actually kind of messy, which I know is surprising for those of you who know me. I love mess, but sunscreen mess is a whole different kind of mess. So I prefer the cups, but there's lots of different ways to use them to test different types of sunscreen. All right. So the other thing I like to do with the sun to sort of make those UV rays sort of visible, those things that we can't see. We can see light, we can see the brightness in the sun, but we don't get to see those UV rays, and those are the ones that can be the most damaging to us. So I like to use sunprint paper. Now you can, if you don't want to use sunprint paper, you can do the same sort of activity with construction paper, but you need to leave it out in the sun for a long time. If you've ever left construction paper on your bulletin boards a little bit too long, and you've seen sort of the imprints from the things that were left there, that's what's happening there. The sun is basically bleaching the paper around the paper that's exposed. I like to use actual sunprint paper because the changes are so quick and they're so obvious, and you have a beautiful sort of print at the end. Since we're talking about summer, combining this summer activity with your Father's Day gifts is a great idea because you get this really, really cool art. If you're someone who's already doing things like tools and whatnot, making sunprints with like washers and different tools can make for a really, really great Father's Day gift. So what I want to do is I want to show you really quickly sort of the tips and tricks on how to use this sunprint paper. So we're back to my camera here. This is an example of a sunprint that I made myself. You can see I made one using natural materials and made ones using man-made materials. Again, this is good Father's Day gift. So this can also be incorporated into your living and non-living units. There's lots of different ways to use them. Now it can be a little tricky, and each set of sunprint paper has its own instructions on how to use them. So follow those instructions. Trust me, you want to follow the instructions. But what happens when you get a piece of sunprint paper is it looks just like a blue piece of paper. And what you do is you stick that blue piece of paper in the little frames they send with it. Now, they typically only send like one frame, but what you can do is you can use just sort of any clear, heavy thing. So you can put it under a piece of acrylic or a piece of glass. You can get all of them underneath. So what I'm going to do is, I don't have the sun right here, but I'm going to show you a little bit about how quickly it works. You want to pick things that are generally pretty flat, so they make a nice crisp outline. So while I'm talking to you, I'm just going to shine my little, there we go, UV, there we go, over top of it. And we're going to get a little bit of a print. It won't be quite as good as when you have it out in the sun, but it will give you an idea of how sort of quickly this works, okay? What you want to do is you want to pick things that are flat, things that have nice crisp edges, but also experiment with layering. Put some fabric or some mesh or some tulle on there, and you'll get some really neat patterns. If you put things that are a little more three-dimensional, you'll get some shadows, which might be interesting and might be something you're looking for. All right, now this was not nearly long enough, but you can see around how the edge the edge of my leaf here looks a little bit lighter. What I'm gonna do is I'm gonna move my tree. So even in that little bit of time, you can see the shape of my leaf. Now, if you were doing this with your class, you'd want to leave it in the sun until it was nice and white. Everything that's blue turns nice and white. But for now, you can see sort of how quickly it works. Oh, someone asked, would laminating sheets work? They would. Really, all you need is something to hold down all of the leaves and things that you have chosen, because you don't want them to move around. Also, don't do this on a windy day. That's my next suggestion. Windy days are sort of a nightmare for making sun prints, but it's a really, really fun activity. So after you get your prints, after you see all the blue turn white, you're going to rinse it under water because that stops the chemical reaction. So this is a little bit different than what was happening with our UV beads. So the ink that is on the sunprint paper, basically under the UV light starts a chemical reaction. So you put it out in the sun, there's a chemical reaction going. If you didn't rinse them when you were done, they would all turn white. The water stops the chemical reaction right in its tracks. So you're left with these beautiful, crisp images. Now, when I showed you my drawing, when I showed you my picture, the leaf where it was sitting was dark blue. And I said, you want the area around your picture to be white. When you dip it in the water, it'll flip. So you can see here that all the things that were laid on there are white and the outsides are blue. It's a really, really neat way to get your students looking at those changes. They're chemical reactions that happen very, very quickly and are very, very obvious. That flip of color is really neat to watch. And again, it's sort of making what's invisible visible to your students. Now, I've got some great things there, but to use as objects for your sun prints, the sky's the limit. Try lots of different things and you'll get some really, really neat prints. One of my favorites is actually this little, these look like origami cranes. Now you can see where they laid flat, it's nice and white, but towards the edges where they were sort of lifted up from the paper, you get more of a shadow effect, which is very, very neat. So experiment and have fun with it. It's a lot of fun. All right, so how likely are you going to use these? How likely are you to use these sun activities in your classroom? Are you going to be investing in some UV beads? Are you going to get some sun print paper? Let us know. These are the things that help to inform us to what we're going to do next time. Okay, so go ahead and let us know if you're going to use these sun activities. Okay, if you've seen me, if you've been with me before, you know that I love books. I love books, and books in the early childhood classroom are so important. So I'd like to talk a little bit about some nonfiction books, which will be great for your summer lesson plans, and then we'll talk about some fiction books too. Now, nonfiction books, I don't like to use them necessarily for story time. Lots of people do. They're not my favorite books to use for story time. I like to put them in centers. I like them to be available for kids to look at and explore on their own and come to me with questions. That's what I want. I want ones that have lots of great pictures, but I also want images. I want photographs. I want diagrams. I want numbers, because those are the things that are going to spark the sort of the best conversations with your students. And it doesn't matter if it's their reading level. If it's above their reading level, still put it in your science center. Still leave it out next to, you know, your sun prints for the day, because there's going to be something there that you wouldn't get in a book that's geared towards younger students. You want to be able to sort of spark those bigger conversations. So some of the nonfiction books, especially the ones that are made for your kids, have mistakes in them. It happens. Some of my favorite books, I've had to correct myself. And those corrections are the corrections that the kids never forget, because it looks different in the book. I usually just like put a piece of tape over it, just write over it. And every single child who picks up that book is now like, what's the tape doing in here? And then we have a whole conversation about what the science is behind that story. So I have no problem taping over errors in books. I've talked about these a lot. Use I Spy in your books, use your post-it questions, but we've got so much to do, so I'm going to keep scooching on. There we go. Come in. We'll go to my next slide. Oh, There we go. All right. So here are some great nonfiction books to add to your summer your summer reading list. So the ones that have little bees next to them are available on the Shop Becker website. So definitely check those out. All of them have these sort of great illustrations and diagrams. You see, I've got a photo book in there, Staying Safe in the Sun. I want to highlight these sort of celestial body books down here. They're really sort of above the reading level. You wouldn't read these out loud to your classroom, but they've got lots of really engaging images in them. So we're talking about the sun. We're about to talk about the moon. Spoiler, because we're talking about the sun and the sky during summertime. So these are fantastic books. They're adorable and they spark a lot of great conversations. They're written from the perspective of different celestial bodies. So you've got the sun, the moon, and the earth. Very exciting. So definitely check out the Stacey McNulty books. They're fantastic. But you also notice here that I've got some nocturnal animals, because we're going to move right on in a little bit to nighttime, so the moon and nocturnal animals. So that's why there's some books on there. Now, this is the last of our seasonal science series, because there's only 4 seasons, as Leslie pointed out before. So I did want to highlight some books that were for all 4 seasons. And it's really great to spend some time, whether you do that in winter, sort of the end of the year into the new calendar year, or if you do it in summer because it's the end of the school year. It's either time works for sort of going over everything we've talked about, how the weather has changed, how the animals have adapted. And I absolutely love this one right here. It's a poetry book, and it's meant to sort of evoke the song, the 4 seasons. So it's an orchestra story. It's very beautiful. Definitely check that one out as well. All right, let's go to the moon. Talked about the sun. Okay, the moon can be a little tricky. Talk about the moon really any time of the year. I like to talk about the moon in the summertime, because that's when I like to talk about things like camping. And I like to talk about looking at the stars, because the kids are staying up a little bit later because it's summertime. So, but really the moon and nighttime learning can happen any time of the year. It's just summer is my favorite time because it's not so cold that we can go out and look at things like the moon and the stars. So talking about the moon, kids have definitely seen the moon before. There's lots of pictures that are in tons of books. So sort of, again, making that moon sort of more tactile for the students is sort of my priority for when we're talking about the moon. So let's go to my camera again. I want to show you my craters of the moon activity. So I'm going to flip over. There's my little thumbprint. I'm going to move it. Now, you may have seen this before. This one can get a little messy. So for those of you who don't like mess, which I know is sometimes the case, this one may be one you want to take outside, because it does get a little sort of powdery everywhere. All I have here is a pie tin with a thick layer of flour at the bottom, and then I've sifted some cocoa on top. Now, if you can't use any sort of food, any sort of food in your science center in your classroom, you can try using different kinds of sand, different colored sand. That could potentially work, though it's not gonna give you the same craters that we would have gotten with things like our cocoa and flour. So if you ever look at the picture of the moon, it's not perfectly smooth. Because much like the Earth, it's been hit a lot by asteroids and meteorites. So to sort of replicate how the craters in the moon got there, we're just going to take our little projectiles, our meteors and our asteroids, and all we're going to do is we're going to drop them into our moon. So we're going to drop them on the surface. We've got some big and some little, and we've got some heavy, and we've got some light. And before you take away the asteroids, I want you to make sure that your students are making some predictions. What do they think it's going to look like underneath each of these things that have hit the moon surface? So let's start with our heaviest one here. So the reason we do 2 different layers is so that you can see very clearly how the crater was formed. So you can see that there is some dark cocoa at the bottom. But underneath, we've got our white flower. And you can see that with all of our craters. Now, you notice that our really light crater, our shallow crater, you can't see much of the white. These are all fantastic observations that you can make with your students as you're talking about the different surfaces of the moon. Now, but why does the moon look the way it does? Because you'll see kids will often comment on how the moon changes, how it's a different moon. We've got a crescent moon, we've got a full moon, we've got no moon. And it's a really, really hard concept. It's a difficult one. So I've got my moon here. You can take any sort of ball. I've got it's a foam ball. As long as you have half of it white and half of it black, it can help you to demonstrate why the moon looks different night after night. So I'm going to come back to my camera here. Now, this can be difficult. So we're going to pretend that you are the sun. Okay, so you're the sun, you're just so sunny and bright and cheerful. And you are shining on my moon. Okay, which means the moon looks white because all the sun's bouncing off that sun. And so as the moon goes around me, the earth, it stays white to you because you're the sun. Now I'm the earth. Right now, when I look at the moon, all I see is black because I can't see the bright sun side because it's not facing me. But as that moon goes to this side, again, you're still seeing white as the sun. But if I turn my head, that's what I see. I only see half of the moon. And then if I move the moon over here, again, facing the sun, you're the sun. And I look over, I only see half the moon again. So this can be a way to show your students how when the moon goes around the earth, how all that bright moon is always facing the sun. But when we're looking from the earth, that's how we see all the different phases of the moon. See? Now we see more of the moon, and now we see less of the moon. So it's a really, really tricky one for you to work on with your students, but there is some advantage to having that sort of the black and white on your moon to sort of hit home the idea that the moon's not changing shape. The shape is still exactly the same. We're just seeing different parts of it, and the parts we're seeing are sometimes lit by the sun and sometimes not. Okay, and all of that is on this slide here. So when you come back to see the presentation, the recording, you can take a little bit of a deeper dive in how we do the phases of the moon ball. All right. So animals, I love animals. If you were here earlier, you heard me talking about my chickens. Animals are some of my favorite topics in science. So I couldn't talk about the moon, I couldn't talk about nighttime without talking about nocturnal animals. Nocturnal animals are fascinating and unfortunately, probably something your students will not see in person. Because nocturnal animals are usually pretty good at staying away from loud and bright things, which is when you go outside with a preschooler. It's loud and it's usually bright. So you probably won't see them in person, but there are ways to sort of talk about them and bring them into your classroom even when they're not around to see. My favorite activity is bat and moth. Now we all know that bats use sonar to help figure out what's going on around them. It's not true that bats are blind. They can see. But this sort of sonar capability and their excellent hearing makes them wonderful hunters at night. And your students can sort of practice being bats out in the night and hunting for their food. So if you played the game Marco Polo, all you gotta do is change it from Marco Polo to bat and moth. Your bats say bat and your moths say moth. And so your bat has to listen to hear when its bat comes back as a moth. Okay, and so they have to find the moths just based on what they hear around them. So it's a really fun, easy way to start talking about those nighttime critters and to take something that kids have probably heard about bats and sort of ingrain it in sort of their play as you're talking about nighttime critters. And then there are owls. Owls are my absolute favorite animal. They are fascinating. And their senses are something that we could easily talk about in the early childhood classroom. First of all, there are their eyes. Okay. Now, if you ask kids to tell you something about owls, they're going to tell you they can spin their heads around. Truth is, they can't spin their heads all the way around. It's not like The Exorcist. They do have some limits to how far they can turn their head. But they can turn about 270 degrees, which is much farther than we can. And the reason they do that is because they can't move their eyeballs like we can. They have a little bone around each eye that stops them from moving their eyes around. So as we can turn our head here and keep looking with our eyeballs, we can keep turning a little bit up and down. Owls can't do that. So to mimic this sort of owl-like eyeball, now we're not going to be able to see as far as owls, and we will not be able to see in the dark, but take some paper towel tubes and lash them together. And you can have your students pretend to be owls just like this, because it sort of mimics the phenomenon of not being able to move your eyeballs around. So talk about how it feels different. Can you see all the same things that you were able to see when you were able to move your eyeballs around? Not exactly. And then, of course, their hearing. They have fantastic, fantastic hearing. So owls can hear things that are some owls can hear things about a half a mile away. Okay. So like a little bug crawling through grass and they can hear it a half a mile away. It's amazing. So spend some time testing your own hearing. Have your students close their eyes and listen for different sounds, have them move farther and farther back. And how far can they go before they can't hear the noise you're making? Stick to very sort of soft sounds to start, and then go to much, much louder sounds. So one may be a beetle crawling through the grass, so maybe a soft shaker egg. And another might be a squeaking mouse. Maybe that's a bell. So the owls can hear a squeaking mouse much farther away than they can hear a little beetle crawling through the grass. And you can mimic that by practicing with your own ears and listening for different sounds. So talk about those nighttime animals. They're some of my favorite topics. All right, glowing. Now, I can't show you too much of this on my camera because it is simply too bright in here. And if it were dark, you wouldn't be able to see it. But summer is a fantastic time to talk about glowing. So we had our UV beads already. They change color under UV light. You can also experiment with glow in the dark beads. Now, those are a little bit different. They fluoresce. Okay. And fluorescing is different than reacting to UV light. Fluorescing means you take in the light and you give back a different light. That's why things that are glow in the dark are usually sort of that green or yellow color. So that's fluorescent. That's a little bit different than what we saw with our UV beads. Our UV beads didn't glow, but glow in the dark does. So I've got a very fancy word that I want to hear more preschoolers saying, and that's chemiluminescence. It's such a fantastic word. I would love to hear tiny people say chemiluminescence, because basically all that means is it's when we have a glow or light or energy coming from a chemical reaction. We see this all summer long with our glow sticks. Glow sticks are fascinating. I always have like a pack of glow sticks in my freezer at all times. Am I the only one who keeps them in my freezer? Keeping them in your freezer is a really good idea, and you can show why with our little glow stick experiment. All you really got to do, it's super simple, is you have 3 cups of water, room temperature, warm, tap warm. You don't want it too hot or you'll melt the plastic, and cold. So put some ice cubes in it. Break your glow sticks, put them inside, and watch. And you will see right away that there's a big difference between the warm glow stick and the very cold glow stick. So if you look at my picture here, because again, I couldn't get a very good picture on my own, this one right here on the right is our warm water, okay? And this one over here is our cold water. So if you can test things like, is it brighter or is it not as bright? Does it last longer, which is why I keep mine in the freezer when I'm not using them? Or does it sort of fizzle out really quickly? The chemical reaction happens when you break that glow stick. When you break it, there's 2 different chemicals inside. They have little glass vials. And when you break them, they're released and they mix. And when they mix, that's when you get your bright, beautiful colors. Now, this happens in nature too. Fireflies. I love talking about fireflies in the summer. They're usually an early summer situation, so better get on your lightning bugs or your fireflies. I wonder if you call them lightning bugs or fireflies where you are. This is a type of chemiluminescence, but it's called bioluminescence because it comes from a living or biological creature. So fireflies are doing the same things your glow sticks are doing, except they're doing it inside their body, and they can do it over and over and over again. So fireflies use those blinking lights to talk to each other. So it's a lot of fun to take your flashlights, shut off the lights, and try to chat with each other using your blinking lights. Figure out that maybe 2 blinks means yes and 1 blink means no. I did it twice. 1 blink means no. There we go. So ask your students questions and have them answer like fireflies would do. It's a lot of fun. I love talking about sort of this nighttime glowing during the summer. All right. How likely are you to use any of our nighttime learning? So that's the moon activities with the craters, and we've got the nocturnal animals, and we've got all of the cool glow stuff with our glow sticks and our fireflies. Let me know if it's something that you might use in your classroom. All right, I'm going. I'm trying to make sure we have time for everything today because I love talking about science in the summer. So before we get to my next set of science experiments, I want to talk about some fiction books. Now, I come from a science museum. I spent a long time working at the Academy of Natural Sciences in Philadelphia. And, science is very serious. And we never want to give the impression of sort of wrong science or things that aren't correct. But I find in the preschool classroom, using fiction books can be a fantastic way to start really good conversations with your students. First of all, they're much better for read alouds. Fiction books, especially fiction books that have sort of a science lean to them, make for much better read alouds than nonfiction books. And when you pair them with those nonfiction books, it gives your students an opportunity to look at fiction and nonfiction and see where they overlap and see where they butt up against each other. It leads to more depth to their conversations about science. And what I love about fiction books is they can give you a lot more of sort of the scientific spirit. You can find books where characters are curious, where they search for solutions and they do experiments and they research and they mess up and they fail and they learn from it. And I also love that they can often change their minds. When you're reading a nonfiction book, it's kind of like, well, this is the answer. This is the way it's always been. Everybody knows that. But fiction books give you the ability to look at a science topic from the learner's perspective. So don't be afraid to use fiction books, even if there's something sort of non-factual about them. Even when I was at the museum, I always snuck in those fiction books because they were my absolute favorite thing to teach with, especially at this age level. So some great summer fiction books. You may remember Pup was also part of my kitchen science from last summer. I want to say it was from last summer because Bubbles, fantastic time to talk about bubbles in the summer. And we've got some other wonderful books that either take place during the summer or have characters that are learning about things that sort of fit in with the summer idea. Maybe it's sun, maybe it's heat, maybe it's warmth. But I wanted to highlight these books down here at the bottom. I like these 3 books because they show kids without adults experiencing nature. What's really great is we've got kids working together in all 3 of these books to learn more about the world around them. So in the sandcastle that Lola built, we have kids working together to sort of build the biggest sandcastle. Things happen. Spoiler, the sandcastle gets ruined by the waves, and they've got to figure out how to come back from that. So it's a really great way of showing kids problem solving and working together. And with the hike and the camping trip, we've got students who are sort of experiencing the world. Maybe they're apprehensive when they start out on their journey into the summer sun, but they learn so much from each other and from being out in nature. So these are some of my absolute favorite books, especially to share during summertime, to get kids thinking about spending time outside and learning together, maybe without adults sort of leading the way, which I think is a huge deal, and they're fantastic stories. And since we were talking a little bit about nighttime science, these are my absolute favorite two books about nocturnal animals and spending time at night. They are not the most factual books about nocturnal animals. There are plenty of great books about owls, and there are plenty of great books about skunks and that sort of thing. But these two books, they're just the color palette and the joyfulness of all the characters. They can sometimes take the fear out of spending time outside at night or in the dark, and they make it more of a positive thing. They're fantastic, fantastic stories. Flashlight was also part of the kitchen science webinars from last year. It's a wordless book that is great for sort of exploring that idea of being out in the dark and shedding light on some of the things that might seem scary about being outside at night. All right, so we went from dark. So now we're going to talk about all the things you can see when it's bright outside. So rainbows. Rainbows, we love rainbows because rainbows sort of show up all the time, and they are sort of one of those catch, you got to catch a rainbow and then you can start talking about. They're great sort of learning opportunities that happen all the time. They happen when you're washing your hands and you've got bubbles. They're happening when you're watering your plants outside. But rainbows can also give you the opportunity to explore that light again. Now, what I'm going to do is, I've got cocoa everywhere from the last experiment. Unsurprising. What I'm going to do is I'm going to show you a way to use sort of old CDs to get kids thinking about how light moves around. So I'm going to switch to my other camera here. Come on, there we go. Stop sharing. So what I got here, other than a lot of cocoa all over my table, is I've got a CD that's just sitting in a pot of water. And I've got a little bit of clay here so that the CD doesn't roll away. So I'm going to move my camera up a little bit, because what I'm going to do is I'm going to take a flashlight and I'm going to shine it on my CD. And you can see on my wall there all of those beautiful colors that come from shining light on the CD. Now, if we look at the CD here, you can see those rainbows, okay? And this makes for a great sort of experimentation tool for your students, because you can give them the CDs and you can give them all different sorts of light sources and let them experiment with making sort of the rainbows appear. Now they can also trace the rainbows if they can get them to reflect on different surfaces. They can, you can make a little dark box, which basically is just a cardboard box that you've put construction paper in, and now you've got a nice little dark box so that you can have that light sort of shine around a little bit better. But there's lots of sort of tools that you can let students experiment with on their own. This is sort of inquiry at its finest. Give them all the tools and let them see if they can make those rainbows. So just the supplies here are all things that you can just sort of put out and let your students experiment. Again, I got that DIY dark box, just put some black paper inside a cardboard box. And students will start to realize that colors look brighter or darker depending on if there's other light sources. So why is there a rainbow when you shine a light on a CD? So light is, as we saw sort of at the very, very beginning when I was talking about the sun, visible light, it looks white to us, because what we're not seeing is we're not seeing all of those sort of bands of color. So if we were to break color up into all of its different wavelengths, at least the visible light part, if we were to break it up, we would see blue light and red light and green light and yellow light. And all of those colors sort of come together and our brain interprets it as one color. So when we're shining our flashlight at our CD, the CD sort of breaks up those waves. It sort of breaks the light into each of its individual colors. And so our brain is able to sort of process them each at a time. But they shift. There's some interference. So we don't just see bands of red, green, yellow, and blue, all the colors of the rainbow. They sort of shift on our CD, which is a really, really neat phenomenon. And it helps us to remember that light is made up of all different colors, at least the lights we can see. Never mind all the light we can't see, like UV light. So light is fascinating, and getting kids sort of excited about how light can change depending on the source and where it ends up is the first step to really understanding energy and the sun and how our eyes and our brain perceive things like light and color. Okay, so I'd be willing to go out on a limb and say most of you do some sort of firework arts and crafts around the 4th of July. Maybe it's salt fireworks, maybe it's glitter fireworks if you're really brave. I could never get into the glitter fireworks. Again, sunscreen, glitter. Those are the two messes I'm not going to mess around with. But we do a lot of sort of firework arts and crafts around the 4th of July. Impossible to do the actual science of fireworks because there's a lot of combustion and fire. So we're not going to do actual firework science. So the two activities I want to show you now the science concepts are not related to actual fireworks, but they mimic some of the shapes and colors that you would see in real fireworks and do teach some neat sort of science concepts, just not about fireworks. So the first one I want to show you is called a firework in a jar. You may have seen this before. It's very similar to an activity I did in the summer when we were talking about water. And it shows a lot of the same principles that when we were talking about not only density, but we were talking about hot and cold water and how they move differently depending on their temperature. So we're going to make some fireworks in a jar. So I'm going to flip over to my other camera so you can see them. Okay. Oh my gosh, there's just so much cocoa everywhere. Okay. Here is my little glass of water. Now this water was cold. It's very warm in the room that I'm in. It had ice cubes in it before. Cold water is the best to start with here because again, cold water, those molecules move slower and you'll be able to see your experiment a little more clearly if the water you're using is colder. And what I got here is what's gonna make my fireworks, all right? This is just a little container with oil in it. You can use whatever oil you have around. I'm using vegetable oil. You can use baby oil. It's nice and clear and it shows up really nicely, but really any sort of oil. And there's also little specks in it. That is food coloring. So I added some blue food coloring to my oil. And as you well know, water and oil don't mix. And food coloring is largely sort of water with a little bit of pigment and alcohol in it. So it doesn't mix with my oil. So I'm going to pour it in nice and slowly. Oh, well, okay, it didn't work. The beauty of doing it live. It didn't work the way it was supposed to and the way it had worked before. But there is a picture. Thankfully, there is a picture on associated with the write-up for this that shows it working very well. The beauty of doing these things live is sometimes they work and sometimes they don't. What should have happened, and what has happened every other time I've done the experiment, is when you pour in the oil sits at the top, and as the food coloring, which is more dense than the oil, comes to the bottom and reaches the water, it sort of explodes under the layer of oil. So you sort of see these little fireworks of color. Again, you can see pictures of it on the write-up for these activities, because unfortunately it didn't work terribly well with my fireworks here during the live presentation, but that happens too.
Holly, you're among many teachers. We all know how that happens every day in our class, and the unexpected happens, and we are ready for it. So no worries on this end.
It happens.
Yeah,
it happens.
Absolutely. We've all been there.
All right. So again, the science behind that particular activity has nothing to do with fireworks. Again, fireworks it's chemistry and it's combustion. We're not messing with chemistry and combustion in the preschool classroom, but it does you could talk a little bit about the temperature of the water. Try the experiment with warm water or cold water. Talk about densities. Why did the oil and the water not mix? And why did the oil sit on top and not actually come down through the glass, though this time obviously it did. So again, the science topics are a little bit different than actual fireworks, but it's a neat way to sort of introduce these topics as you're already talking about the 4th of July and you're talking about fireworks in your classroom. So I've got another fireworks activity. This one will hopefully work a little bit better than the last one. And we've got the same sort of thing here. So I've got a piece of paper, and I'm going to come up a little bit higher. Whoop, whoop, there we go. I got a piece of paper, just a piece of construction paper, and I've got some water with food coloring in it. It's just regular, run-of-the-mill water with food coloring, okay? And I've got my pipette here. Pipettes are fantastic tools to be using with the early childhood classroom. They can be found in just about every science center. They're found in the Becker Science Center kit. Very exciting stuff. And they're a great way to sort of practice those fine motor skills. And in this case, make our own little splatter fireworks. So what you can do is start by taking a little bit of your water and being relatively close to the paper, put a drop down. Does that look like a firework? No, it doesn't really look like a firework yet. But what happens if we come up a little bit higher? Now what do we have? So what we can start doing is we can experiment with how high and how much water we're splattering on our paper. And then what I like to do with kiddos is I like them to use markers or crayons and try to find, let's see, where's the one that's the farthest away from our firework here. And I like them to sort of circle where they think their firework is going to go. So if I say, I'm going to start here, how big do you think your firework's going to be? Let's find out. So that's about as big as our firework is. So it's a little bit messy. You definitely want to do it outside. It can be one of those things that you do on the blacktop while you're getting ready for, you know, if you're brave, your glitter activities. If you're not brave, your solve activities. And this is a great one to sort of talk about those shapes you see in the sky, show some videos without the sound on, because as we all know, the sound is the most terrifying part of fireworks. But this is a great way to sort of explore those shapes and then to talk a little bit about the physics of it. Why did it splatter more when I held it up high versus when I held it down low? So it's a great way to sort of introduce these ideas, these sort of complicated physics ideas while you're already doing a unit about fireworks and the 4th of July and all of that great stuff. All right. So both of those fireworks activities, again, with a picture of when it worked, are going to be available after the webinar. I think the team's already been sharing those links with you. So definitely check them out, and it's got more step-by-step. I think I'm running out of time, so you'll want to try this one on your own. It's very, very, very simple. All you do is put a couple of drops of milk in a glass of water and then shine a flashlight in it. It's that simple. The water and the milk will do what the sky does. We get the question all the time, why is the sky blue? Everyone thinks they're so clever when they ask why the sky is blue. Like, we don't know. Well, we do know why the sky is blue, and it has to do again with all of those colors that you find in visible light. So the air isn't clear. Okay, it has all sorts of specks of dust and all sorts of other things floating around in it. And when the light comes through our atmosphere and comes through that air, certain wavelengths come straight through. And that's the picture here. You can see the yellow and the orange and the red. They come straight through. So visible light, the red, the orange, and the yellow come straight through. But the blue and the purple, they get sort of scattered by all of those things that are in the air. And when they get scattered, they don't quite make it to Earth the same way, or don't quite make it to your eyes the same way that the red and the orange and the yellow do. So our eyes perceive the sky as being blue, even though it's not. It's just all of that blue those blue wavelengths are getting scattered by the dust and all the other particles in the air, and it sort of gives a sort of blue haze to our atmosphere. So that's why the sky is blue. Now, if you do the same thing with your glass of milk and water, the little the milk particles inside the water do the same thing. When you shine the flashlight in, they scatter the light, making it your milk look blue, just like the sky looks blue. It's very neat. Try it yourself. All right. Are you going to try are you brave enough to try the fireworks experiment that did not work for me in front of all of you today? Are you going to try to see if why the sky is blue? Are you going to try fireworks in your classroom, of course, without the big boom? Experiment with rainbows in your classroom. Let us know. Okay. Whew. We made it with 5
breath.
minutes to spare, Leslie. We got 5 minutes to spare.
Amazing. Well, don't you worry. We
Yeah.
have many questions for you. So just let me give people a couple more seconds and then we will end the polling. And we've had a really nice response to the polling. People have been
I'm
great.
so excited to see.
Yeah, that's just so great. So we're going to end that and we will just save those results for you later, Holly. Um, Fantastic. As always, there are some questions. I know
Sure.
one that came up during one of the early experiments was where are they going to get those UV beads? Because unfortunately, we do
Yeah.
not offer those through Becker's.
So that you can find them in lots of places. Amazon has them. What you want to be sure you're looking for is either sun beads or UV beads, not glow in the dark beads. Glow in the dark beads look very different. They're the ones that like sort of we're used to, that sort of greenish, yellowish color. You charge them up in the sun and you bring them inside and they keep glowing. They're different and they will not respond the same sort of way. So you want to look for UV beads or sun beads. You can find them in lots of different places, like craft stores sell them, that sort of thing.
Great.
Yeah.
So I just saw somebody put in the chat that they thought this started at 4, and it did start at 4 Eastern time. So I'm sorry if
Oh
you were in a different time zone, but this you can see in the chat that we will put links where you'll be able to get the recording. No worries.
no.
So just quickly, if you have a few minutes to spend with us, we have named this discount promo after our wonderful trainer that we love so dearly, Holly. So Holly 20 will get you a 20% discount off of a lot of the science materials that were discussed today, mentioned today, and some of the other science things that we have in at shopbecker.com and in our catalog if you don't have that yet. And if you just take us to the next slide, Holly.
Of course. I forgot I was in charge of it
Yeah,
there for
right?
a second. There we go.
I think we've mentioned this every time, but just so that you know, Holly loves books. I love books. We at Becker's love books. We put together a full 4 seasons book set so that you always have these books at the ready. A lot of these Holly has referenced over the last
Mhm.
4 sessions. I mean, obviously, it's a lot of books and it's a little more expensive than some of you are used to spending after some of these webinars, but this will really get you through the year. And because we know that preschool teachers share so nicely, I'm sure you'll share with the other classrooms. So it's something for you to think about while you get this 20% discount. So lots of book sets for you to look at. Next slide. And,
Oh, yeah. So I was talking about this the whole time, the kitchen science, because so much of this is perfect for summer. It's all right there. Those great books, water and light and color and bubbles. Ah, so exciting. Go ahead.
and right, and we worked with Holly and she created these lovely activity cards for us. If I hold it here, you might be able to see.
Yeah,
So
we
it's
see it.
not only the book set that we talked about at Kitchen Science, but it is all these great activity cards that just make it so easy to use these in your classroom. Promo code Holly20, and the that promo code is good through May 31st. So you don't have a lot of time to think about it. I think you just have to act. So Holly also worked with us on we put together this Becker's Science Center. It's just kind of really updated and improved from what we've had in the past. So this has all the tools. It works with all the different areas of science that you're going to want to have at the ready to just, you buy this and you have your Science Center ready to go. And the last thing that Holly has collaborated with Becker's on is developing this set of science cards. And this, might I say, hot off the press. I just unwrapped my very own set today. So these really complement the Becker Science Center, but also can be used independent of the Becker Science Center. So they're activities ready to go for you. So please check it out. I won't go into details, but they're really cool. and there's 18 activities, and you just put them out. You put the tools out, and the children do the rest. I mean, they basically use everything that Holly's been talking about as far as their observation skills, their prediction skills, all the things we want young children to be doing during science activities. And that last, maybe the last slide, is coming soon. We always have something exciting that we want to share with you. And that is that Holly's going to be doing a series of these, what we call science shorts. They're going to be how-to videos with a lot of these science activities that she's done for us. We know it's always better when you can kind of see it live and in person. So they will be coming and be available to you soon. So please continue, get on our emailing list, our email list if you are not on it yet, and continue to stay tuned on shopbecker.com, and we will let you know. Holly, do you want to give us a little heads up? I think, we're pretty much going to have these in early June,
Yeah, yeah.
mid-June,
And
ready to
yeah,
go.
it's all about using the tools and using things like magnets and water and shells and rocks and all the great stuff that you might already have in your science center, and how to encourage sort of independent inquiry learning with them. It's very
Yeah.
exciting.
Yeah, which is just great. So I think that, let me look at oh my gosh, 501. Amazing. So
Amazing.
a huge, I mean, it only took 4 of these to get it down, right? I think we have it now. So I want to thank Holly. She's done a tremendous job for us. And I want to thank all of our participants, because you've just been so lovely and how interactive you've been. All your positive comments have been so encouraging and reinforcing to what we're trying to do to help you out here. So thanks for coming. Thanks for being here. If there are any questions we did not answer, Holly will take while everybody's just kind of wrapping up, we'll take another quick look.
Yeah, I'm starting to look through right now. Yeah, if you have any questions, just pop them in the chat and I'll do my best to answer
I'm
them.
just not sure I understand this one. Are these trainings going to switch to STARS hours in the future? I'm not sure I understand that. So if you're still with us, if you maybe can rephrase that question for us. Can we see a sample of the science cards? I can hold one up here. If you're still on.
Yep.
Because I'm using a green screen, things get a little funky. So I think if I keep it right here, probably if I stop sharing my screen, you'll be able to see it a little better.
Okay,
So
let me
let
stop
me,
sharing. There we go.
yeah. Let's see. So, and if
Turn
we,
my camera off.
I'm still kind of little, but that's okay. So for example, this card's going to say, just collect some items that are made from metal and some items that are not made from metal, and then put out some magnets, ask children to touch each object with a magnet and sort them by which items are the magnet attaches to and which they don't. We use lots of flashlights in these activities. We shine a flashlight on each metal object and see what happens. We do a lot with water. Let's see what else we have. We cover living and non-living things. We do a lot with properties of materials, so the physical science. We weigh materials. We see how objects react to water being added to them. We talk about different, again, properties, bumpy, soft, hard. So we cover a lot of science in this nice set of cards. So definitely something you might want to check out. We wish all of you a great summer as well, and hope to see you again soon. I'm going to shut my video off. We will continue to check your chats and your comments and respond as best we can. Thanks again for coming. Can't wait to see you again.